Alright, welcome to another video. So in these practice problems here, I'm going to go through how to find all the different attributes, key features for an exponential function given a graph and part of a table. We're not actually going to write out the equations for each of these, but you totally could if you wanted to. So looking at this first one, the first thing I try to do is I want to figure out all the missing terms in my table. To do that, what I like to do, number one, you got to find a common ratio between the terms. So what are we multiplying each y by to get each consecutive y term in the table? To do that, I like to take my second y, I like to call this y2, divided by my first y, call it y1. Okay, just whatever two consecutive y's in your table that you know. All right. Now, lucky for me, I've got a handy dandy calculator app that I just downloaded from TI. It was free for 6 months. It's fantastic. So just type in 600 divided by 1200, and I get 0.5. So this means this is actually my growth or decay factor. Now in this case, looking at the graph, we can tell that this is definitely decay because our graph is going down from left to right. So we already know that this box over here, this blank, is actually 0.5. Okay. Now, to fill out the rest of my table, I know I kind of jumped ahead a little bit. What we want to do is just take 300 and multiply it by 0.5. And we get 150, and that makes sense. Okay, half of 300 is 150. Okay, and if you need to use the calculator to figure out to fill in the rest of it, you can. I know half of 150 is 75, and then half of 75 is going to be 37.5. Okay. We already said this is a decay. So you can write in the word decay or you can just circle it. I'm just going to circle it for now. And that's because this is decreasing from left to right. And yes, it is a decay factor. So you can circle these, you can fill them in. It's up to you. So big thing here, y-intercept. Okay. You always want to find where x is 0, and that tells you your y-intercept, which in this case is 150. Okay. Now you could have probably looked at the graph and estimated this is about 150 based on the other y values and where we cross the y-axis. But we already know from the table that the exact value is 150, so that's what we want to use. In some of the previous videos, I talked about the asymptote of the exponential function. And so remember, this is that imaginary line that we're approaching, but we're never actually going to reach it. In this case, it's going to be the x-axis, or y equals 0. Okay. Domain, the big thing for domain, and the same is going to be true for range, is we want to look at those endpoints. Because we have arrows on both, on the left side and the right side for my domain, we know that's going to be all real numbers. And for our range, we know we can't equal 0, but we still have this arrow up here at the top. So that means our range is going to be y greater than 0. All right. So that's example number 1 on how you would complete the table and all the key features based off of the information provided. All right. I'm going to let you guys can try to figure out number 2. I think we should jump down here and take a look at number 4. Okay. Number 4 is a little bit different. Okay. The only thing that's really different about number 4 here is the endpoints. So that's going to change up our domain and range just slightly. First thing I would do, let's fill in our table. Okay. Again, This is my second y that I know, my 128. This was my first one, so we want to divide y2 divided by y1. Again, let's go back to our graphing calculator. Okay, so I'm going to type in 128 divided by 160, and we get 0.8. Okay, so we know our factor here is 0.8, which matches the graph because our graph is going down from left to right. Therefore, this is a decay graph, and our rate of decay is 0.8, which makes sense. It's less than 1. Anytime your rate is less than 1, then we're talking about exponential decay. If it was greater than 1, we're talking about exponential growth. Okay, now let's go back and find our y-intercept. All right, so if I want to go backwards, okay, so we've been multiplying to get the next term. Well, the opposite of multiplication, if we go backwards, is division. So we can start with our 160 and just divide that by 0.8, and we have our original starting point of 200. So we can write that in right here. And if you look at the graph, that matches the graph. We started at 200. Our y-intercept should be at 200. Okay. Now to figure out the other ones, 102.4 times 0.8 is 81.92. And then take that times 0.8, and you get 65.536. So 81.92 and we had 65.536. Okay, y-intercept was 200. Asymptote still hasn't changed. It's y equals 0. Domain. Now here's where we don't want to use all real numbers, because my smallest x does not have an arrow here. Okay, it actually starts at 0 and it goes on forever because of this arrow here. So my domain is actually x greater than or equal to 0. Okay. Range is also going to be a little bit different, okay, because we know because of our asymptote we can't cross 0, okay, but we also have an upper boundary up here at 200. Therefore, my range is going to be from 0 to 200. Now notice here, I didn't put less than or equal to because we can't equal 0. But I did put equal to here because we did start out at 200. That was our starting point. Okay, so just pay attention to those types of things. We can never equal the asymptote. We should equal the starting point. Okay, unless you see an open circle there, which I don't think we're going to give you one with an open circle. Okay, so those are just two example problems from this worksheet. That should be enough to kind of help guide you guys through the rest of these. Just make sure anytime you want to work backwards, divide by your factor. If we're going forwards, multiply by whatever your common ratio is, that growth or decay factor.